Good day everyone. Today we'll discuss probability in counting methods part 1. After the completion of this module, students should be able to number 1, define probability and analyze and solve different cases in probability. By definition, probability is the measure of the likelihood that an event will occur. So from the figure, probability goes from 0, which is impossible, to 1, which is to certain. Okay. Then for the formula, probability is the ratio of total numbers of ways that event can occur to the total number of possible outcomes. So it is usually represented as a decimal or fraction. So where E is equals to number of successful outcomes and S is equals to total number of possible outcomes. We have now different cases in probability. For number 1, single event. Single event probability is used to find the probability for a single event that occurs for an experiment. So for example, consider tossing a coin. We will get a single event, either head or tail, as an expected result. Second is multiple events or compound probability, is when the problem statement asks for the likelihood of the occurrence of more than one outcome. So from the figure, we can turn this item, then we can have different results, 1 to 6. Number 3, mutually exclusive. Two events are mutually exclusive if they cannot occur at the same time. Disjoint is another means of mutually exclusive event. So if two events are disjoint, then the possibility of them both occurring at the same time is 0. So we have a formula here. P, A or B, event A or event B is equals to PA plus PB, where PA is the probability that event A may happen and PB is the probability that event B may happen. So we have an example here. Find the probability of drawing either an ace or a king in a single draw from a deck of 52 playing cards. So here, probability of ace is 4 over 52, meaning you have 52 deck, and the probability that the ace king can occur is 4. Then is equals to 1 over 13. The another one is the probability of king that occur is also 4 over 52 cards. Then is equals also to 1 over 13. So those mutually exclusive event of A and B is equals to PA plus PB using this formula. So equals to our PAs is 1 over 13. Then our P king is 1 over 13. Those our final answer is equals to 2 over 13. Number 4, non-mutually exclusive. So when two events A and B are non-mutually exclusive, there is some overlap between these events. The probability that A or B will occur is the sum of the probability of each event minus the probability of the overlap. So here is our formula. So PA or B is equals to PA plus PB minus P overlap A and B. So we have some example also here. Find the probability of drawing either an ace or a heart in a single draw from a deck of 52 playing cards. So for PAs, same, we have also 4 ace over 52 deck cards. So this is equals to 1 over 13. And P hearts, so we have 13, 1 to 10, then jack, queen, and king. So we have 13 heart over the 52 deck cards. So PA or B is equals to PA plus PB minus P A and B. So use this formula. It's equals to 4 over 52 PA. Then the P hat is 13 over 52. Then PA and B is equals to 1 over 52. Then PA's or heart is equals to 4 over 13. Number 5, repeated trials. The probability that an event will occur exactly R times out of n trials. So we have this formula, P is equals to NCR times P raised to R times Q raised to n minus R, where P is the probability of success, Q is probability of failure, and n is equals to number of trials. So we have an example here. A fair coin is tossed 5 times. What is the probability of getting exactly 3 heads? Solution, P is equals to 1/2. So this 50% success that it will be heads or tail. Then Q is 1/2. So the failure also is 1/2. Could be head or it could be tail. Then the number of trials is 5. And R is equals to 3. So we have to find the exactly getting 3 heads. So this is the successful outcomes. So P is equals to 5C3 by giving the data. So from our formula, n is 5. So P is 1/2, R is 3. Then we have the failure is 1/2. Then n is 5. Then 3 is the success outcomes. So equals to P 3 head, probability of 3 heads is equals to 5 over 16. Number 6, complementary probability, or at least one condition. So this is the probability that an event will occur exactly at least in n trials. For our formula, P is equals to 1 minus Q, where Q is the probability that an event will totally fail. So for example, an urn contains 5 white, 3 black, and 2 red balls. In getting 1 ball, what is the probability that it is not red ball? So from here, from our formula, we have a total of 10 balls. So the probability here that it is not the red ball is, we have 8, and we have 2 red balls, so 2 over 8. So solution, P not red is equals to 1 minus Q red. So 1 minus 2 over 10. So we have all 10 balls here, and the red is only 2. So it's equals to 8 over 10. So if we reduce the equation, our final answer is 4 over 5, or equals to 0.9. Number 7, conditional probability. Conditional probability is the probability of one event occurring with some relationship to one or more other events. So we have formula, P, A, and B is equals to PA times P under B over A. So where PA is the probability of event that it may happen, PB is probability that event B may happen, and PB over E is equals to probability of B without A. So we have an example here. An urn contains 3 white balls and 1 black ball. Determine the probability of drawing 2 white balls in succession from the urn without replacing the ball after each drawing. So we have here 4 balls, 3 white and 1 black. Solution. So for our first probability, we have 3 white balls over total number of 4 balls. So 3 white possible successes out of 4 balls in the first draw. Next is, of course, we already get the one white ball, so meaning we have only 2 white balls left and a total of 3 balls. So PB over A is equals to 2 white balls over 3 total number of balls left, equals to 2 white possible successes out of 3 balls left in the absence of one formally drawn above PA. Then PA and B is equals to 3/4 times 2/3 those, so you have to multiply. Our final answer is 1/2. Number 8, independent probability. This is the probability that A or B will occur is the product of the probability of each event. So for our formula, PA and B is equals to PA times PB, where PA is the probability of event A may happen and PB is the probability of event B may happen. So for example, one bowl contains 5 white balls, 2 red balls, and 3 green balls. Another bowl contains 3 yellow balls, then 7 black balls. And what is the probability of getting a red ball from the first ball and a yellow ball from the second ball in single draw from each bowl? Okay, solution. P red. So for the first bowl, we have 10 balls, so we have 2 red here. So there are 2 red balls out of the 10 ball. Then P yellow, the second bowl. So another bowl contains 3 yellow balls and 7 black balls. So there are 3 yellow balls out of 10 balls. Okay. The next, PA and B is equals to 2/10. So we have to multiply their probability. So those are final answer is equals to P red and yellow is equals to 3/50. This ends our presentation. Thank you for watching. Our next topic is part 2, theory of set, will be uploaded separately.